Okay. Good afternoon, everyone. It's a pleasure to come again in front of you to discuss some doubts in case if we have. So those who are already present, please, introduce yourself through this chart so that I know who are all there. Then probably we can start uh, some discussion. Is anyone is around? Please write your name and introduce. Hi, Vaishnavi. You have any questions? You have any doubt? Welcome you to this live session. Hi, Cheryl. How are you? PhD, PhD student in chemistry from which place? Okay, one or two doubts from previous assignment. May I know what is that? You have those? Mhm. If any doubts are there, okay, probably I think. Did you send any mail to me? Just go ahead and write down your doubts. Can you tell about your doubts, Vaishnavi? Well, unless you write it down, I cannot answer, right? What is HCP? What is HCP? What is HCP? HCP. Yes. Did I use that HCP abbreviation somewhere? Or I think Vaishnav is asking in a short form. Question 5 assignment. Yeah, question 5 assignment 2. Okay. Well, I don't remember. I don't. Yeah, I will come to that one in a minute. Okay. Oh, okay. Okay. This HCP is, phosphorus in +3 oxygen state, and it's almost like an acetylene. In acetylene, one CH group is replaced by phosphorus. Of course, that is a very unstable compound. In order to have that one, you have to have very bulky group. But nevertheless, okay, one can think of that molecule. Okay, HCP means CH single bond is there, and there is a triple bond between carbon and phosphorus, essentially replacing one of the CH groups in acetylene with P, phosphorus. Is that clear? Yeah, is that clear? In case if you want to make multiple bonds between main group elements, it's very difficult except for the first row elements. Okay, that is carbon, nitrogen, and all those things. If you go further down, because of larger size of p orbitals, overlapping won't be very efficient. As a result, what happens? The multiple bonds will be very weak. In case if you want to enforce a double or triple bond between main group elements, you have to have very bulky groups. You can do it kinetically. Is it clear? Well, PC bond is not very stable. That's what I told you. This bond is not very stable. Okay. Because phosphorus has a lone pair and it can get oxidized readily to form PO. And also it can be pyrophoric also. What is your other doubt? Cheryl, you have any questions? Some more people have joined, it seems. Why don't you just introduce by writing your name and from where you have come and what you are doing? Those who joined later, you can just introduce and ask questions if you have any. If there are no more questions, probably I may have to close it down. Okay. Yeah. So this we have in both in if you consider both the compounds, okay, both have two SCl bonds, and then one has S2O double bond and one has S2N triple bond. And if you want to the so if you want to see the percentage stronger. Yes, okay. How it has influence on S bond length. No, electron density is pulled towards N. Yes. But C and chlorine and nitrogen more or less very similar electronegativity is there for both of them. And triple bond, single bond, okay. Yes, okay. Yeah, basically what happens, S character increases if the hybridization, moves from sp3 to S. If you take sp3 hybridization, in that one 25% and 75% is there, right? S character. And if you go to sp2, you have 33.3% and 66.6% is there. And if you go to sp, 50% s character and 50% p character is there. If s character is more, then basically bond strength increases. So based on that one, you can tell the bond strength, SCl bond strength is less in case of uh, in this one. In this one, it is less because it takes more. So in case of, if you take, where sulfur to nitrogen bond is there, bulk of S character is taken away by nitrogen. As a result, what happens? SCl bonds will be little longer compared to the other one. Okay, so this is how you can analyze. So if you look into sulfur, the comparison is about sulfur to chlorine bond here. Okay. In one case, you have triple bond N. In one case, you have thionyl chloride, SOCl2. So you have S2O double bond. Okay. Is that clear for you? Because if you consider both of them, in both of them, S is sp3 hybridized. Which question that is? The same. The same. Same. Also plus 4, and this is anionic. This one. Okay. So if it's anionic, you don't have triple bond. There's a double bond, N minus is there. Okay. You don't have triple bond. That's wrong. You got this one from literature or you wrote? That's incorrect. Hmm? It's like amide. Okay. Right. NH is there. NH3, NH2, NH. Okay. NH minus, that is. Beryllium carbonate in water. Can you explain the solubility of beryllium? Okay. Beryllium carbonate, if you just look into the ionic size, Be3 plus and Be2 plus and CO3 2 minus. Okay. How do you arrive at the solubility constant? Okay. If the difference in the ionic size increases, for example, barium sulfate, if you take, barium sulfate is highly insoluble, right? Solubility is related to hydration energy. In hydration energy, what would happen to hydration energy when you go for any carbonate? If you go from, uh, go down the group, beryllium to magnesium, magnesium to calcium. calcium to rubidium and then cesium. That increases. Yeah, that's what. Yeah. So beryllium is least soluble. And then if you go to the higher ones, what happens? Water of hydration, water of hydration, hydration energy increases means, you can have more water molecules surrounding that one because of the larger size. So hydration energy increases when you go down the group, and as a result, solubility increases. If you consider all alkaline earth metal carbonates, uh, the least soluble one is beryllium carbonate. The most soluble one is cesium carbonate. That also explains sometimes when you are using some of those things in catalysis also. Hydration energy decreases means it can be readily, hydrated, right? Yeah. No, here this when the lattice energy decreases down the group, okay, ions will be well separated. Yes, when the ions are well separated, hydration will be very facile. Okay, they can readily interact with water molecules. Okay, of course, water can also be polarized. You can see that one. Okay, H plus and OH minus. And then when the interaction increases and more ionization is there, basically solubility increases. Yes, it is, uh, it can be correlated to the ionic character. The increase in ionic character is essentially due to the decrease in the lattice energy when you go down the group. Any other question? Which assignment is going on now? Hmm? Fifth assignment. Nine. Okay, because we're close to March, Yeah. Hmm. Okay, barium green, it's basically, if you just look into alkaline earth metals, okay, if you start heating, the electrons will be excited. So from where the electrons are going to where? It basically you have S2 electrons are there, right? S2 electron, when it's excited, it becomes S2P1 electronic configuration. Okay, when it goes to S2P1, of course, from spectroscopy, you know that. Okay, whatever the energy absorbs, complementary color will be seen. Okay, if the green is it appears green, means opposite to that one, what color that comes? Maybe violet. Okay, violet Vib Gaia, right? Yeah. Um, well, it's intermediate. Okay, uh, maybe blue color. That means it absorbs blue color, means it emits green color, something like that. Okay, so that's the reason it depends. Huh? If the green color it comes, it takes red. Red, right? Yeah. So if it absorbs the energy needed for promotion is in the red region. Okay. So when it takes that one, uh, uh, the the red portion is totally absorbed, and as a result, it appears green. So the color is complementary, and this color appearance is due to the excitation of electron from S to have S1 P1 electronic configuration. And if you recall your knowledge of transmetal chemistry and electronic spectroscopy, it is Laporte allowed. Okay, Laporte at delta L equals plus or minus 1. Okay, it is allowed. As a result, what happens? It has very high epsilon absorptive coefficient and it is very intense. It shows green color. Calcium shows red, brick red or crimson red, it shows, right? And strontium shows crimson red. And calcium shows brick red, I think. The color can be directly correlated to the energy associated with the electronic transition from S2 to become S2, S1, P1 electronic configuration. It is not green flame. The flame, when it is burning, that appears green. Yes. Yeah, that appears in case of if you see in case of firework also, yeah, BSCl plus is responsible. Yes. In lecture number 4 or 5, I think I had discussed about this. The the colors imparted to the flames by alkali metals and alkaline metals. I had discussed it, and also I have given equations for some of those things that I have shown there. The species that's responsible for imparting the color. Mm. Yeah, obviously, if you heat it, it start decomposing, right? Okay, if you when you start decomposing, basically Cl minus goes, okay, and then you'll be left with BaCl plus. Really not correct. BaCl plus. Okay, it is basically it is something else. So what I feel is it's basically takes sodium, okay, sodium, elemental sodium, okay, and if you heat it, okay, it gives golden yellow flame. Okay, there it is. S electron is there. It goes to P, S0, P1. In the same way here also, I don't think BaCl2. Okay, and probably what we see is atomic barium comes out. Okay, and during that process, and then electronic excitation happens from barium. S2 electron become S1 P1. I don't think, well, in what way BaCl plus imparts green color, let me look into it and get back to you, okay? And I'm not quite clear about that one as of now, but certainly BaCl bond, you can ionize, okay? You can cleave that bond. When you cleave that, Cl obviously leaves a Cl minus ion, and you have BaCl plus cation will be left, okay? But whether any interaction is there, that gives green color after the dissociation of Cl minus, I should look into it. Okay, let me get back to you. Maybe tomorrow I shall answer that question. Just drop a mail to me, Vaishnavi. I will answer that one. Okay. Because the characteristic flame test, what we see in case of alkali metals and alkaline earth metals, is essentially the excitation of the valence electron to the orbital, next empty orbital. In this case, what we have is p orbital. Yeah, you just okay. I will get back to you maybe tomorrow evening by okay. Any other question you have? How about others? Okay. Then have you taken the other course also, interpretive spectroscopy? Okay, then I wish you all the very best in whatever you are doing it. Okay, if you have any doubts, as I said, you can always write to me and I shall try to answer your queries. Okay, thank you. I can close it here. Here, here, close here. Okay. Okay, here it is. The next one, कुछ लिखना हो। Okay. ओ इसमें ओपन रखा है सर, वो आप डायरेक्ट लिख सकते हैं। हाँ, no, इसमें हाँ।